Now that we've reviewed in class how to take an absolute value equation and turn it into a piecewise function without absolute value bars, we're going to look at how to take that new piecewise function and use it to help us to evaluate a definite integral that involves an absolute value equation. So I've got some steps here. So notice the first step tells me to do that process that we reviewed in class. I want to rewrite my absolute value equation without absolute value bars. So doing that, I'm going to go ahead, just like we did in class, I'm going to take my inside function and set it equal to 0. Solve that and I get x equals 1. So when I create my piecewise function, I know that one piece is going to be less than 1 and the other piece is going to be greater than 1. Remember, it does not matter where you put your equal to, so you can do that now. I typically put mine with the piece of the function that doesn't have the negative out front. Then I'm going to ask myself, if I pick an x value less than 1 and I plug it into my function without absolute value bars, do I get the same result as I get with the function with absolute value bars, or do I get the opposite? So when I plug 1 in, I see I get 2 minus 2, or excuse me, when I plug a value less than 1 in, say 0, I get 0 minus 2 is negative 2. Since I'm getting a negative and absolute value is always positive, I know that that gives me the opposite of what I want. So I'm going to go ahead and use negative 2x minus 2 for x values less than 1. And if I try something bigger than 1, say 2, notice I get 4 minus 2 is 2. I get a positive, which is the same thing I'll get with the absolute value bars, so I'll leave the function alone for that piece. So now my integral, I want to go from negative 1 to 2. Well, notice that from negative 1 to 1, I have one function, but from 1 to 2, I have a different function. I'm going to use that to break up my integral and take the integral of each individual piece. So from negative 1 to 1, I'm going to integrate the function negative 2x plus 2, so I distributed that negative in. And from 1 up to 2, I'm going to integrate the function 2x minus 2. When I integrate my first function, I get negative 2 over 2 x squared plus 2x from negative 1 to 1. I know negative 2 over 2 is just negative 1, so I'm going to rewrite it like that. And then I'm going to add, I didn't put that in there, I'm going to add these two integrals together. So doing the same thing with my second integral, I integrate and I get 2 over 2x squared minus 2x from 1 to 2. And I'm just using that general power rule to get that 2 over 2x squared. If that doesn't make sense, please let me know in class and I can kind of walk you through that. And now I'm going to go ahead and do top minus bottom using that fundamental theorem of calculus and add my two answers together. So when I plug 1 in, I get negative 1 plus 2 minus my bottom function, negative 1, which is still going to give me negative 1, but now minus 2. As you heard, my phone rang, so I paused the video, and I apologize if I overlap, but I've plugged both 1 and negative 1 into my first one. I'm going to go ahead and drop my plus sign down, and I'm going to do my second one, and I'm going to plug 2 in and get 4 minus 4 minus my bottom one, which is going to give me 1 minus 2. So when I do all this, I'm going to get an answer of 5. And feel free to go through and work through it. I don't think it's useful for you to watch me sit and do basic math on this video. But all I've done is kind of done some order of operations and found out what all of this adds up to be. So let's look at the second example. There are 2 examples total. Second example is a little bit more complex than the first one. However, my steps are going to be the same. The only thing that makes it a little bit more complex is the fact that I have a quadratic inside my absolute value bars. But I set that equal to 0. I solve, and I get x equals plus or minus 1. So that basically means that I'm going to have a couple different intervals, a couple different areas. I'll have an interval below negative 1, from negative 1 to 1, and then above 1. So when I set up my piecewise function, it's going to have 3 pieces. So x values less than negative 1, x values between negative 1 and 1, and x values greater than 1. So now I'm going to go ahead and test kind of each area. So let's say I pick something less than negative 1, I pick negative 2. When I plug negative 2 into this function, does it give me the same thing as I get plugging it into this one, or does it give me the opposite? Does it give me a negative? Well, negative 2 squared is 4 minus 1 is 3, which is the same thing I would get with absolute value bars. So I do not have to write the absolute value bars. It's just the same function either way. If I pick something between negative 1 and 1, say 0, and plug it in, 0 squared minus 1 is negative 1. And if I look here, 0 squared minus 1 is positive 1. So I'm getting the opposite. So I'm going to have the opposite of x squared minus 1. I tried to make my x better. I think I made it worse. On the bottom piece, I picked something greater than 1, say 2. 2 squared minus 1 is going to be positive 3, which is also what it's going to be with absolute values. So I just rewrite my function. And now from here, I'm going to go ahead and I want to integrate from negative 2 to 1. So I'm going to go ahead and take this piece, and I'm going to go from negative 2 to negative 1. And then I'm going to take this piece and go from negative 1 up to 1. Notice I do not need to use this piece at all. It ends up not being necessary for my integration. So I'm going to go, as I just stated, from negative 2 up to negative 1 and have x squared minus 1. And I'm going to add to that my area, or my antiderivative, from negative 1 up to 1 of negative x squared plus 1. And then integrating each piece, I integrate the first piece and I get 1/3 x cubed minus x from negative 2 to negative 1 plus negative 1/3 x cubed plus x from negative 1 to 1. Now I can go ahead and use the fundamental theorem of calculus twice and add my results together. So the first one, I'm going to go ahead and plug my top function in, for my top value in first, and I get negative 1 cubed is negative 1, so negative 1/3 plus 1 when I plug in negative 1, minus I plug in negative 2, I get negative 8/3 plus 2, plus I plug in 1 and I get negative 1/3 plus 1, minus I plug in negative 1 and I get positive 1/3 minus 1. From here I go ahead and do my math, and doing my math gives me 8/3. Again, I don't think it's necessary for you to watch me do a bunch of fraction work, so if you want me to show you that, I can definitely sit down with you in class and show you how that works. Please don't hesitate to ask me. But that's going to be it for your video on using the fundamental theorem of calculus with absolute value equations.